Very good afternoon, my dear students. In our last class, we already discussed about the course outcomes and the syllabus, introduction to the machine learning and key components of the machine learning. Today, we will go through the well-posed learning problems in the machine learning. So before that, what is the definition of this particular learning? So how we are going to learn the one particular task? So the computer program is said to be learn that is to be happen from the experiences with respect to the class of tasks and the performance P. So here experience is denoted by the E, performance is by P, and class of task is declared by the capital T. So we have to learn this particular program based on these three attributes: experience, task, and the performance. Okay, now for this condition I want to consider the three different examples. One is the checkers game, second one is handwritten recognition, and third one is robot driving. So coming to the first example, that is checkers learning problem. So what is my task? My task is to playing the checkers game. Okay, so for any problem we have to first note down the task. The task is what we want to do. Okay, my task is playing the checkers. And next one, performance. Okay, how many games I won. So that is the percentage of games won against the opponents. That is my performance, and that is measured by the P. And next, training experience. How could I got this particular knowledge to play against the opponents? That is my experience. So guys, here the checker game is to be explained, or the task is to be done by the first playing the checkers, and that playing experience, that knowledge is obtained by my experience by playing against itself or myself. Okay, so by that knowledge I want to do the I want to play the game against the opponents. Okay, so by playing that condition, how many number of games I won, that's my performance. Okay, so now I move on to the handwritten recognition learning problem. Handwriting recognition. What is my task? My task is to recognize the handwritten words. Okay, so how could I recognize? Based on the experience, training experience. Okay, so that is nothing but the database of the handwritten words given the classifications. So if I know that writing thoroughly, then only I can identify. So for that, this task is to be done by this experience. Okay, so because of this database we can identify. So what is my performance? The percentage of words, how many words I can identified correctly or classified correctly. Okay, so for this handwriting recognition condition, my task is the recognizing the or classify the words, and next to performance is how many words I can correctly identified or classified, and third one is experience. Okay, so a data set of the handwritten words with the given classification. Okay, now move on to the third example, third well-posed problem in machine learning, that is the robot driving the learning problem. Robot driving, what is my task? So robot is automatically drive the motor or a car. So that is the task. So driving on public 4-lane highways using the vision sensors. Why? Because robot can be saw by these vision sensors. So that is the task. So what is the experience? How that robot can has the knowledge? That knowledge is provided by the data set of sequence of images and the steering commands recorded while the human driver can do. So this robot can behave like as a human driver based on that his commands and the steering, and that one is position of the seating. All the things is to be observed, or the data set is provided to that. Based on that, it has the from experience. or that knowledge. So by that knowledge, how can we measure the performance? That distance is traveled before an error occurred. So the robot driving is, the task is to drive the robot by use of the vision sensors. Okay, next performance is how much kilometers it can traveled before an accident occur or the first error comes. Next, how he got it got the experience. It takes the commands of the drivers, okay, human drivers, okay, steering commands and sitting positions, all those conditions, it has the data set. So by these three conditions, or any problem can be explained with the help of these three attributes. One is the experience, second one is task, and third one is the performance. So for that, I gave the definition as, okay, so the computer program is said to be learned from the experience E. That experience is with respect to the class of tasks and the performance P. Okay, so if its performance at task T as measured by the P, that is improves with the experience E. So how can I improve my experience? How can I improve my performance? That performance increment is to be happen by this particular experience. If you have the lot of experience, that experience is nothing but a lot of data set you have. Based on the data set, your performance can be increased. Similarly, we already explained in the key components of the machine learning. In that condition, first one is learn from the data, third one is the training and evaluation, and third condition is continuous improvement. That continuous improvement is to be happen due to our experiences only. Okay, so for that we can easily solve, or we can easily classify the any task with respect to these three conditions: task, performance, and the training experience. Okay guys, yeah, next we move on to the designing a learning system. How we can design one particular learning system. Okay, here we have the 5 different stages to learn one particular system. So the first one is choosing the training experience. Very important one, and the basic one is training experience. Without proper training experience, we can't go ahead. Why? Because in the key components of machine learning also, learn from the data set. Okay, so that learning is occurred due to this training experience only. So next one is target function. Okay, which type of functions we want to consider, or what are the attributes we want to consider, and which type of experiences we can inculcate, all are decided by this target function. And next one, third one is a representation for that target function. Which type of weights we can use. Okay, so in table manner or in which manner we can represent the target function, that is decided in the third condition. And next, fourth one is function approximation algorithm. In this function approximation algorithm, we estimate the training values and the adjusting the weights. Okay, after completion of all these steps, and we move on to the final design. Okay, so guys, now move on to the first one. Yes, choosing the training experience. This training experience can be considered by the 3 different words. Training experience. From my concept, we can got this particular training experience by use of the 3 different words. The first word, the first design choice is choose. Second one is degree, and third one is represents. Here, coming to the first design choice, I choose the type of experience. So what are the different type of experiences? Here I can mention the 2 different conditions of the feedback. One is direct feedback and indirect feedback. So whenever we have the one particular knowledge, in that knowledge, if you done anything wrong, okay, that feedback comment or the thing is to be occurred in the two different conditions. One is by ourselves, that is the direct, or second one is by others, that is the indirect feedback. Okay, so here the choosing the training experience, that is to be considered in direct and indirect feedback. And next, second one is degree. So this degree is to how extent you can control the sequences, or how extent we can control that particular task. Here I considered the checkers example, checkers game. In that condition, if I'm unable to move forward or to face the opponent, in that condition I want to take the suggestion from the trainer or else teacher. Okay, so this degree is indicates that how extent we can control the sequences of the training examples. Okay, so next one, third important attribute, that is the representation. Okay, so for this representation, yeah, we consider the final system performance P must be measured. That representation is to give the best performance. Okay, so guys, here the choosing the training experience is to be based on three conditions. One is choose the training experience, second one the degree, the learner how extent the learner controls the sequence of the training examples, and third one is the training experience is how well it represents the distribution of all examples. Okay, the next one is second one, choosing the target function. Okay, for this checkers game, I have a lot of legal moves. Okay, out of those all legal moves, we try to consider the best move. Okay, that move can give the win chance to me. So that is the best move I consider. So for that condition, so I select the function which is the choose move. That move is to be represented B to M. Here B indicates the state boards, okay, and M indicates the moving position, okay, state of the move. Yeah, here my example is the checkers game, playing a checkers game. For those condition, my target function is represented as V. Here B is the on state boards, so V of B is considered. Okay, so what are the possibilities while playing the checkers game? Whether we won the match or lose the match, and third one is draw the match. Okay, so whenever I won the game, that is represented by the 100. Okay, so lose condition is represented lost condition minus 100, and drawn is represented as 0. Apart from these conditions, and fourth one is there, that is V of B equals to V of B dash. Okay, this B dash is the special one, that is the best final board state. B dash is the best final state board. That means that each and every state from the starting onwards, we consider the optimal move until the completion of the game. Okay guys, it is ideal condition. Compulsory while playing the game, we may intentionally or intentionally we try to consider some unnecessary moves. Okay, but whenever we consider that B dash or that move is the optimal until the game completion, in that condition V of B equals to V dash B. Okay, so like that we consider the target function. Next, after considering the target function, we want to represent that particular target function. Okay, so for this condition, yes, V is the target function here I considered. Okay, the function is to be represented with some different type of variables, x1 to x6. Okay, so each and every variable is associated by the different weights. Okay, so here w1 to w6 I have the 6 different weights, and x1 to x6 are the different variables. Okay, so my approximation function v cap of b is represented in those conditions as here v0 to v6 are the numerical coefficients or weights. Out of these 6 weights, okay, v0 is called as the additive constant. additive constant. Apart from these W naught, remaining all are relative importance to the various board features. Okay, here the weights W1 through the W6 will determine the relative importance of various board states. Okay guys, yeah, next fourth one is function approximation algorithm. So in the previous condition, I just considered the V cap of B. Now for this condition, I'm trying to estimate the training values in place of these values V of B and V cap of B. I try to consider some V train of B. So these are called the training values. How can we identify the training values? These training values are nothing but the successor values of V of B. So that is V successor of B. So V trained B is the successor value of V cap of B, and that is represented as B comma V train of B. So like that we can estimate the training values. And next, adjusting the weights. So for these adjusting the weights condition, we measured the squared error or mean square error. Okay, so that is difference between the train value and the V cap of B value. Okay, so if these two values are the same condition, in that error equals to 0. And next one, the final condition. Here I want to note down these Wi in terms of Wi and eta V train of B minus V cap of B into Xi. For those condition, if these two values are equal, V train of B is equals to V cap of B, V train of B is equals to V cap of B. In that condition, this value is equals to 0. Only we have Wi equals to Wi. In that condition, weight is no change in the weights. Okay, so whenever this V train of B is positive, this is positive. If it is positive, in that condition, the value is multiplied with this condition, and it is a normal value. Its value is approximately 0.01. Like that, smaller values you can consider. Okay, so the value is to be added with this Wi. In that condition, weight is increased. For these two are equal, there is no change in the weight. Whenever it is positive, the weight is increased. So by these conditions, we can adjust the weights as per our requirement. Next, coming to the final design. For this final design, first we start with the performance system. This performance system takes the initial game board as the input, or this performance system provides the solutions, okay, by the game history, and that is given to the critic condition. Okay, from this critic we give the some training examples. V train of B, all the training values are given to the generalizer. Whenever this generalizer takes the training examples, okay, so it can use the hypothesis that is to the experiment generator. Okay, so whenever the experiment generator provided by these different type of hypothesis, H1, H2, okay, all are subsets of the H, it can generate the new problem. Okay, that new generated problem is to be performed by my performance system. It is the final design. Okay, so guys, now we want to conclude this particular condition at the task. First one, here I want to explain all the things whatever we studied for this particular case. Okay, designing a learning system. We have the first one is training experience, second one is target function, third one is a representation of the target function, and fourth one is function approximation algorithm, and fifth one is final design. Okay, so guys, now I came here Yes, first one is determine the training experience, my first one. Second one is determine the target function, and third one representation of the learned function, that is nothing but the target function. Representation of the target function, and next determine the learning algorithm. How we are noted this particular value? Representation of the approximation algorithm. So here that is mentioned as the learning algorithm. This approximation algorithm. Okay, and next final one is completed design. So that is our final design. Okay, so if you learn these particular values, okay, we can easily note down the remaining entire answer. Okay, I will give the clarity to that. Okay, so for this condition, to determine the training experience, what are the things we considered? Yes, games against the experts. Next, games against self. So that is the feedback against yourself, direct feedback system. And next, games against the experts is the indirect, and how extent you can control the sequence of the moves with the help of the trainer. And next, how can we represent to increase our performance? Okay, all are explained in this training. Determine the type of training experience. And next, determine the target function. The target function is to be represented based on the best board move or best move, that is explained by best move. Okay, so that is B to M, best move. Even though we have the lot of legal moves, okay, out of all those legal moves, we considered the best fit move. That move, by that move we may get the winning chance. Like that values, like that moves we want to consider. That is the, by that we can determine the function. Okay, so next one, determine the representation of the learned function, or the representation of the approximation learning algorithm. So it is done by the polynomial value or set of functions. 6 values we can represent now. So function equals to w0 plus w1 into x1 plus w2 x2 and so on to w6 h6. Okay, so that is the linear function of 6 features. Suppose polynomial, so this condition we can consider the polynomial values also, and this representation is also done by the ANN, artificial neural networks. And determine the learning algorithm, so that is linear programming we can consider. So based on these consideration of the algorithm, so the approachment is changed. And final, completed the design. The design is of, yes, performance system, and next one is critic and generalizer and the experiment generator, and this procedure is to be continuously done. Okay, so guys, I hope you understand this particular 2 topics. One is well-posed learning system, and second one is designing a learning system. Thank you. We'll meet in the next class. Bye.